Hey developers, Steven here, and in this video I'm going to make a quick presentation on determining if a number is prime in Python. We're going to do that by writing a quick isPrime function that takes in an integer that will be the number, and this will be an int, so we'll use the typing library here to indicate what our parameters are and what it will return, and it's just going to return a boolean if it is prime or not. And what we need to do for this is first, a lot of people say that 1 is not prime. A prime number is only prime if it's divisible by 1 and itself and nothing else. But 1 is only divisible by 1 and itself, but it's still kind of not prime. So if number equals 1, return false. We also know that 2 is also prime. So if number equals 2, we're going to return true. And the reason that we're doing this check early is so that we can do a for loop condition that it will allow us to run this function very quickly. So if we put in super large numbers, it won't take 20 minutes to run. It probably wouldn't take 20 minutes to run anyways, but you know, Python can be a little slower than some of the compiled languages like C++. So because of that, we want this to be semi-optimal, and this check is useful for other functions such as finding large perfect numbers and finding large Mersenne primes. Yeah, Mersenne. And the reason that's important is because there's a whole branch in computer science around just finding super large numbers using distributed applications and stuff like Hadoop clusters and things to parallel process and just find massively large numbers with like millions of digits and even more. All right, so anyways, let's continue on with this isPrime. So again, what we want to do is make sure that the number is not equally divisible by itself. So we'll use the modulo operator to do that check. And we want to check every single number that's part of it, and if that's is a equal divisor. So what that means is for I in range, what we need to do is, I think our range will start at 3. I don't think it needs to start at sorry, 3 is prime, and I'm just like thinking in my head, will this actually work for us? I think it will, because it won't go into the loop. For 4 is not prime. Actually, what we need to do, if number equals 2, all right, so now that we checked our if number equals 2, if number modulo 2 equals 0, so if the number is an even number, there's no way it's false, or there's no way it's prime, so we're just gonna return false here. This will allow us to use the step size parameter of the range function to make it so we only need to check every other number, and that's just even digits. That will allow us to optimize our function and run even faster. I think that we can do a square root function, and we're going to get that from math, and we only need that one specific function, so we'll just import that one directly. And to again save cycles of the number, we only need to check multiples up to the square root. For instance, if you have 16, which the square root is 4, and it's divisible by 2 and 8, to get up to 8, you will have already checked if 2 is a divisor of it. So you don't need to go past the square root of the number to optimize the problem. And we'll see that in this function. So this will be the square root of our number, and we'll do a step size of 2. Then again, it's similar to our line on number 8. If number modulo, which basically just checks the remainder, and if a remainder of a number divided by another number is 0, then that means it's an equal divisor, thus not possible to be prime. So if number I, or if number modulo I equals 0, return false. And then ultimately, after all this is done, we can return true because it fell through all of our checks, meaning it must be a prime number. And we'll go ahead and check that. Is prime 7. Print is prime 16. Print is prime 31. So this should be true, false, true, if our logic is working. And we'll see if that is the case. Sorry, my text is really big. Float object cannot be interpreted as integer square root. Oh, sorry. This should be int square root because the range function only expects integers. And if you have the square root of a number, say like 15, which obviously is going to be a little bit over 4, like 4.1 something something. Maybe I don't know. You will want to turn that into an int, and int always chumps down. So I think you can do +1. We might be outside of range if we do this. No, because it's for I in range. I don't think we'll be over the number though. Okay, that should be fine. All right. When you're only doing one extra operation, it's not going to add that much latency to your function. And then we have, true, false, true. Everything's perfect there. And this works for individual number checks. We're also going to add on following videos for this to find all of the prime numbers up through 1 and 1,000 using the sieve method. We'll talk about that. And then we're going to follow that up by making a video for finding the first 15 perfect numbers. And that is tricky because you deal with really large numbers. And in university, I didn't actually deal with any programs that did such a thing. So it really kind of stretches your mind on optimizations. So if you're interested in those videos, please subscribe along. And thank you for watching. And I think this will wrap this up for now. Take care. Bye.